Okay, we're trying to solve question 2. It tells you straight away in the question that we're going to use the GDC to find the correlation coefficient and to find the equation of the regression line. So you need to absolutely know how to do that on the calculator. We go to Stat, delete that bit of ink that I put there. We go to Stat, Edit, List 1, there's already something there, so we go up to List 1 and clear, enter. Do the same in List 2, clear, enter. Go back to List 1, and we enter the numbers. 90, 75, and so on. Very important to make sure you don't make a mistake. Trouble with these questions is there's no method marks at all if you make a mistake. So you enter the 10x numbers, the high school grades. You go up to List 2, and you enter the university grades. You need to practice this so you can do it quickly. And that's it. Maybe it's worth having a quick scroll through your results to check they're correct. If you're happy with them, you then need to go to Stat, to Calc, and we want Lin Reg. Okay, the X list is list 1, the Y list is list 2. There's no frequency list in this case. We don't particularly want to save the equation, though it might be useful. If we did want to save the equation, we can press vars, go to Y vars, to function, we choose Y1, and that will actually save the equation that comes up in Y1, which could be useful later on. We go to calculate. And that gives me everything I'm looking for. For part A, the correlation coefficient is the R value which is there, that's 0.76, and I round up to 1. Should always give my answers to 3 significant figures. And in part 2, that's part 1 of A. In part 2, I have to give the equation of the regression line in the form y equals ax plus b. So I have y equals a is 0.0518x plus b, so in this case minus 1.29. It's a little bit strange. There's 4 decimal places here in the coefficient of x, and there's only 2 decimal places in the constant number at the end. Okay, that is correct because they're both to 3 significant figures. Okay, in part B, we've got to describe the correlation. To do this, we're going to refer back to the R value we had before. The R value suggests a fairly strong positive correlation. So the R value tells me the direction of the correlation, whether it's negative or positive, and it tells me the strength of the correlation. In part C, I've got to use my equation line to predict the average university grade for a student who gets a high school average grade of 50%. So the equation I've got, I'm going to copy it, is y equals 0.0518x minus 1.29. The x values are the high school grades, so I'm going to replace the x with 50 minus 1.29. Go back to my calculator to calculate that. I'll quit this screen. That's 0.0518 multiplied by 50, subtract 1.29 equals 1.3. Okay, so a high school grade of 50 doesn't really translate into a very good university grade, as perhaps we'd expect. It then says, state whether this is a reliable estimate. Well, there are 2 things they're looking for here. The correlation is reasonably strong, so the estimate is reasonably reliable, but the x value of 50 is not within the bounds of the data we've been given there. I think the lowest high school grade in the data we were given was 70. So here we are extrapolating. Since we are extrapolating the estimate is not that reliable. And that would be sufficient for the 2 marks.